This scenario is going to take a look at converting OSPFv3 routes into EIGRPv6 and vice versa. There may come a time and place where you have a network that's running two protocols simultaneously, as seen in this one. On the left-hand side, the network is configured to use EIGRPv6, and on the right-hand side, we're using OSPFv3. Now you can see the common middle ground that these two networks have is that they're joined by the corporate router, which speaks both protocols. I'm going to take a quick look at the corporate router and show you what the configuration looks like, as well as the routing tables and the problems that we're trying to solve. When we go into the corporate router, one of the first things that we're going to do is just take a quick look at the configuration. So if we look at our running config, you can see here at these serial interfaces, one of the interfaces is configured for EIGRP, the other is configured for OSPF. Looking a little bit further down, you can see exactly how OSPF is configured, as well as EIGRP. So nothing really happening there other than standard configurations. When I look at the IPv6 routing table, we can see a couple of different things. I'm learning one route, the 14 network, from EIGRP, and a second route from OSPF being the 15 network. If I pull this to the side, scroll a little bit, you can see the 15 network is over here on the blue side between the laptop and Sioux Falls. And the EIGRP route is the 14 network sitting between the laptop and the Madison routers. Now the problem is, I want this laptop, laptop 0, to be able to talk to laptop 1. Let's see how we can accomplish that. We're going to go ahead and start off on one of these sides here, and we can start off everything with the corporate router, and let's go right into our EIGRP configuration. When I go into the corporate router, and jump into config T and do router EIGRP, we need IPv6 router EIGRP, and then our autonomous system number. Now the redistribution of routes is really no different in IPv6 than it was in IPv4. So we're going to use a lot of the same commands, the same metrics and things that you should be familiar with. So when I'm in EIGRP, that means I'm taking OSPF routes and dumping them into that EIGRP protocol. The command is pretty simple. We're going to do a redistribute OSPF. We need to tell it what process ID that's coming from. And this network, I happen to choose process ID of 1. And we set up the metrics. So if you remember, there's 5 K values in EIGRP, and OSPF doesn't carry that information. So I need to take all of those routes coming from OSPF and give them those K metrics so EIGRP knows how to use them. First one that we have is bandwidth in kilobits per second. For this network, I'm going to use 1500. We do our delay metric. We use 10. Reliability score, 255. The effective bandwidth metric, or how much load is on the link, will do 1. And lastly, we have our MT value, so 1500. So pretty simple. We're going to hit enter there, and those are kind of default values that we've gotten from EIGRP. A couple that you might change would be things like your bandwidth and your MTU size in certain occasions as well. Remember, if you change that on one router, that needs to match across your whole network. Let's go into OSPF. So we're going to go into IPv6 router OSPF, and it's process ID 1 in this network. And so we're going to take EIGRP routes and then distribute them out via OSPF. There's a little bit less metrics that go into OSPF, so this translation is slightly easier. We're going to do a redistribute, taking the EIGRP routes from autonomous system 1337. And we'll try that out there. So, really not too bad. We should be able to go and look at these networks after they have a little bit of time to converge and see that these routes have been redistributed out. Let's take a look, fast forward time here, and let's just go to the Madison router and take a quick look at the routing table that exists over here. And here you can see I've got a route. It's coming in from an external source. In this case, it's EIGRP. And this is the 15 network. So what we now see is that the Madison router, so sitting over here, knows how to get to the Sioux Falls internal network. Let's check this out on Sioux Falls as well. If I go into Sioux Falls, just show IPv6 route, we can see we're getting another external route. It's been entered into OSPF. This is advertising the 14 network. Looking at the diagram, we see the 14 network exists between the laptop and Madison. So theoretically, we should be able to ping all the way across this network now. Take a quick look at these addresses just to make sure that we have everything set. Specifically looking for a gateway on each of the laptops. And we're looking good there. Let's try to issue a ping across this network. So if we grab the IP address from that laptop, we've got kind of the link local there. I guess we can just do it the packet tracer way and just grab a packet and go between the two. And you can see down here at the bottom, we've got a successful ping.